The region bounded by y equals root x and y equals x over 3 is the base of a solid with cross sections perpendicular to the y-axis that are semicircles. We're doing a y-axis one instead of the x-axis one, which means we have to solve each for x and integrate with respect to y. So y equals root x, solving that for x is going to have me square both sides, and now I have x equals y squared, no big deal. Taking y equals x over 3 and solving that for x has me multiplying both sides by 3, and I get y equals, or x rather, equals 3y, no big deal. Okay, so if I pick one, it doesn't really matter which one. To find the diameter, if we're doing semicircle stuff, the diameter is going to be just the one subtracting the other. So we'll do y squared minus 3y, why not? Okay, so the radius is going to be half of that. So half of y squared minus 3y. Okay. So what is that? That's going to be half of y squared minus 3 over 2y gross. Now, if we're dealing with semicircles, the area of a semicircle is 1/2 pi times the radius squared. So 1/2 pi times 1/2 y squared minus 3 over 2y squared. Okay? Oh, this is not going to be pretty. That is a perfect square trinomial. So multiplying that to itself is, well, do I want to do that yet? I kind of have to. Multiplying that to itself, I should have not have done that. Oh, I regret doing that. That's too late. It's too late. I mean, what I'll do is I'll just wave my hands. And I'll say that the whole thing is going to be pi over 8 times y to the 4th minus 6y cubed plus 9y squared. Because time is money. Now let's integrate that. It looks like we have to find our limits of integration, so let's find that. It looks like it's from 0 to 8, but I don't want to guarantee anything. I mean, the picture looks promising, but here's the thing though. My limits are dependent on the y's, so I almost blew it right there. So it looks like actually 0 to 3. Let's just double check. The limits are when I take this or these two original equations, original equations, and set them equal to each other. So y squared equals 3y. Subtract 3y from both sides, so y squared minus 3y equals 0. Factor that out. Y minus 3, so yeah, we get 0 and we get 3, so those are our limits. Happy, 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 happy. What's not happy, 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 happy is what's about to happen. I'm going to integrate that guy right there. So let's rip out the pi over 8, go from 0 to 3 of y to the 4th minus 6y cubed plus 9y squared dy. All right, so the pi over 3 is going to still exist out there. You become 1/5 y to the 5th. You become negative 6 over 4, so negative 3 over 2 y to the 4th. And you become 1/3 times 9, so regular 3y cubed. And my limits are 0 and 3. All right, so we plug in the 3, pi over 3, 1/5, 3 to the 5th, minus 3 halves, 3 to the 4th, plus 3 times 3 to the 3rd. Now, common sense would tell me that when I plug in 0, u becomes 0, minus u becomes 0, plus u becomes 0, which is all 0, and times that is 0, so you get 0. So let's not go crazy and write all that stuff out, shall we? This becomes pi over 8. 3 to the 5th is 243, so you're 243 over 5. So that is the same as 3 to the 5th, essentially, because it's 3 to the 4th times 3 again, so you're another 243 over 2. And you're 3 to the 4th, which is 81. Common denominator of 10. So let's multiply u by 2 over 2, so we have pi over 8 Multiplying u by 2 over 2 is going to get us 486 over 10. Multiplying u by 5 is going to be 1215 over 10. And multiplying u by 10 over 10 is going to be 810 over 10. Adding these three fractions up is going to get me 81 over 10. And multiplying these two guys together is going to get me 81 pi over 80. Yuck.